For today's lesson, we will be discussing about angle of elevation and depression. So first, let's discuss what is angle of elevation. So angle of elevation is the angle between the imaginary line of sight and the horizontal line where the object is above the observer. So this is an angle formed again between the imaginary line of sight and then the horizontal line. So the key word here is that the object, or the key phrase is the object is above the observer. So we have to remember, if it's angle of elevation, the object should be above the observer. So here are some illustrations that will help you to visualize the angle of elevation. So in this figure, let's say you have this person right here, and then the object that he or she is looking is the top of the tree, which is this one. So this is the observer, the object is above him or her, so the angle formed is called angle of elevation. So this angle right here, this one. So another example, so we have this line of sight. So again, the object is above the observer. So this is the imaginary line of sight, this line right here, and then this is a horizontal line. So the angle formed, again, this angle right here is what we call as the angle of elevation. Next is the angle of depression. So angle of depression is the angle between the imaginary line of sight and the horizontal line where the object is below the observer. So the one thing that you have to remember here is that the object now is below the observer. So it's the opposite of angle of elevation. So for angle of elevation, the object is above the observer. For angle of depression, the object is below the observer. So here is one illustration. So let's say this is the observer right here, and then we still have the horizontal line and then the imaginary line of sight, which is this PR right here. Then let's say the object is here. So as you can see, the object now is below the observer. So this angle right here is angle of depression. Another example, let's say this is the observer. A boy is looking at the ball, which is located here at the bottom. So the observer, or the object, is below the observer. So this angle formed right here is again angle of depression. So this is just another illustration of angle of depression. Again, just remember the object should be below the observer. So here are just some of the illustrations containing both of the angle of depression and angle of elevation. So if the object, let's say the observer is the dog and then the object is the bird, so if the object is above the observer, so the angle formed is angle of elevation. Now let's say the bird now is the observer and then the object is the dog, so the angle formed now is angle of depression. Here is another illustration. Now let's solve some problems, but this time let's just focus with angle of elevation. So we will have discussion of word problems involving angle of depression on the next video. So first problem, John wants to measure the height of the tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 30 degrees. How tall is the tree? So we have here John. There is also a tree. And then we know that he is exactly 100 feet from the base of the ground, from the base of the tree. And then the angle from the ground to the top of the tree is 30 degrees. Now the question is, how tall is the tree? So whenever you're solving problems like this, it's better if we will illustrate so that we can visualize what's happening. We can also identify what angle are we using. Does it include angle of elevation or angle of depression? So let's draw a tree. So let's say this is the tree, and then let's also draw John. So you can just draw a stick figure if you want. It doesn't have to be so fancy. Now, let's label the things that we know. First, he walks exactly 100 feet from the base. So we know that the distance of the tree to John is 100 feet. So this is 100 feet. Next, he looks up, and then there is now an angle formed from the ground to the top of the tree. So let's just draw here. Okay, something like that. So this is the ground, and then an angle formed from the ground to the top of the tree is 30 degrees. Now, how tall is the tree? So this is now the problem. We have to solve for this. Let's say this is x. So as you can see, since the object is above the observer, so we have here angle of elevation. So we will be using the trigonometric ratios in order to solve for the height of the tree. So let's assume that the triangle formed here by the angles and the sides is a right triangle. So to solve this problem, we will be using trigonometric ratios. So we have a lot of trigonometric ratios, and then you have to identify which one is applicable for this. So how are you going to know which trigonometric ratio is applicable for this specific problem? So you have to look at the given, the one that you have, and also you have to consider the one that you're looking for. So since we already have this angle right here, and let's say that this is the right angle. Let's draw a segment here. This one. So this is the right angle. We have the right triangle here now. So let's now look at the given. So we have 100 feet. And then this 100 feet is the adjacent side of the 30-degree angle. Now, we also have to look at the one that is missing. So this side right here. And this side, in reference to the 30-degree angle, this is the opposite side. So you have to think of trigonometric ratio wherein it involves opposite side and also the adjacent side. So it can be tangent, or it can also be cotangent. So it depends on you which one you would like to use. So we can use any of the two. So to solve this problem, let's try to use tangent. Tangent of 30 degrees. So from what we know, tangent can be solved using opposite over adjacent. So we have to identify which one now is the opposite side, which one is the adjacent side. So we already identified it. Opposite side is the one that is missing, which represents the height of the tree. And then the adjacent side is the distance of the tree to John. So let's substitute the values here. Tangent of 30 degrees is equal to opposite side, we don't know, so that is x. Then the adjacent side is 100. Now, since 30 degrees is a special acute angle, we can already get the tangent of it, which is square root of 3 over 3. So, square root of 3 over 3 is equal to x over 100. Now, we just have to simplify this so that we can solve for x. So, let's just cross multiply. So, this is 100 square root of 3 equal to 3x. Again, just have to cross multiply. And then since we want x, just divide both sides by 3. So cancel. So we now have 100 square root of 3 over 3. Then let's just write feet. So let's write here. Height of the tree is 100 square root of 3 over 3 feet. Then this will be your final answer. So if you will be using the cotangent, you will still get the same answer. So again, in solving problems like this, you have to consider the given and also the one that is missing. And you have to identify what trigonometric ratio to use that involves those values.